At 7:18 on a July evening, I shut off the main breaker to the house while the air conditioner was running. Dinner was cooking, and the refrigerator, well pump, internet router, lights, and freezer were all drawing power at the same time. Nothing stopped. The lights did not flicker, the router did not reboot, and the air conditioner did not even change pitch. Every watt was coming from the structure behind the house. Not the roof, and not a diesel generator, but a gazebo. More specifically, it was a solar gazebo built around a 6-kilowatt photovoltaic array, a battery bank, and an automatic transfer system. From the ground, it looks like a shaded backyard pavilion, but electrically, it functions like a small residential power station. By the end of this video, you will understand how a solar gazebo can power an entire house, what it actually costs, where most builds go wrong, and what you need to calculate before deciding whether one makes sense on your property. The panels are the easy part. The real challenge is making the system survive heat, storms, nighttime loads, and the moment several large appliances start at once. This project began after I received a quote for a conventional rooftop solar system. The installer recommended a system just over 6 kilowatts, paired with enough battery capacity to cover essential loads during an outage. The price was more than $27,000 before incentives. That number was not completely unreasonable because it included labor, permits, electrical work, mounting hardware, and the installer's warranty, but it created 3 problems. The roof was already halfway through its expected service life. The panels would be mounted above dark shingles in a climate where roof temperatures regularly climb well beyond the outside air temperature. And after spending that much money, I would still have an exposed patio that was nearly unusable during the hottest part of the afternoon. That led to a different question. Instead of treating solar as equipment that had to be attached to the house, could the solar array become a useful structure of its own? That is where the gazebo idea started. The finished structure has a footprint of roughly 16 by 20 feet. It is tall enough to feel open underneath, but low enough that the panels can still be cleaned and inspected without specialized equipment. The roof holds 18 high-output solar modules that together produce approximately 6 kilowatts under ideal conditions. The array feeds a hybrid inverter, which directs electricity to the house, charges the batteries, or sends excess energy through the approved grid connection, depending on the operating mode. When utility power fails, the transfer equipment isolates the house from the grid and keeps selected circuits running from solar and stored energy. That last part is important because solar panels do not automatically make a house off-grid. Without the right inverter, batteries, disconnects, and transfer equipment, many grid-connected solar systems shut down during an outage. That shutdown protects utility workers from electricity being pushed backward onto damaged power lines. The first lesson is simple. If you want backup power, design for backup power from the beginning. Do not assume that panels alone will keep the lights on. The gazebo solves the generation problem, but the battery system solves the timing problem. During the middle of a clear day, the array can produce more electricity than the house is using. But at 8 in the evening, solar production drops while the refrigerator, lights, electronics, and air conditioning may still be running. That mismatch is where battery sizing becomes expensive. A lot of people begin by asking how many panels they need, but that is not the first question I would ask. The better question is how much electricity the house uses when the sun is not available. Start with your utility bills and look at annual consumption, not just one mild month. Then identify the loads that must operate during an outage. A refrigerator may use relatively little energy over a full day, but its compressor draws more power for a brief moment when it starts. A well pump can create an even larger surge, while electric water heaters, clothes dryers, resistance heaters, and central air conditioning systems can drain a battery bank much faster than most people expect. This is where an off-grid plan can become unrealistic very quickly. Trying to run every circuit exactly as if the utility were still available often means buying a much larger battery system than you actually need. A better approach is to separate loads into 3 groups. The first group is critical and includes refrigeration, water, basic lighting, communications, medical equipment, and a few outlets. The second group is useful but manageable, such as selected air conditioning, a microwave, garage equipment, or a small workshop. The third group contains loads that can wait, including electric clothes drying, pool heating, large resistance heaters, and other high-consumption equipment. During the grid disconnection test, the gazebo system powered the house successfully because the battery and inverter had been sized around actual loads, not just the panel rating. The system could handle the refrigerator, freezer, well pump, internet equipment, lights, and one air conditioning zone. It was not designed to run every high-demand appliance indefinitely during several cloudy days. That distinction matters because powering the entire house does not mean unlimited power. It means the system can operate the home within a planned energy budget. Now let us talk about the structure itself, because this is what separates a solar gazebo from panels placed on an ordinary garden shelter. Solar modules create substantial weight and wind load. A gazebo roof may look simple, but during a storm, the panels act like a broad surface that wind can push against or lift from below. The posts, beams, connections, footings, and mounting rails all have to transfer those forces safely into the ground. The footings on this build extend below the local frost depth and were sized for the soil conditions. The post bases keep the structural members away from standing water, and steel brackets connect the beams and columns at the main load points. Above that is a purpose-built rail system designed for solar modules. The panels are not screwed directly into decorative lumber. They are attached with approved clamps, bonded together electrically, and positioned so water can drain without collecting against the frames. This is one of the areas where trying to save a few $100s can create a very expensive failure. A neighbor built a smaller canopy using lightweight roof framing and generic hardware. It looked solid during calm weather, but the first major windstorm loosened several connections. The structure did not collapse, but the movement damaged wiring beneath two panels and pulled water into a junction box. The repair cost more than the proper mounting components would have cost at the beginning. The takeaway is straightforward. Build the gazebo as an engineered outdoor structure first and a solar rack second. The panels should never be responsible for holding the frame together. The next advantage is heat. Solar panels are rated under controlled test conditions, but in the real world, output changes with temperature. As the cells become hotter, their electrical efficiency generally falls. Rooftop systems can still work extremely well, but panels mounted close to a hot roof surface have less airflow behind them. A freestanding gazebo allows air to move beneath the entire array. That does not create free electricity, and the exact improvement depends on the panel, climate, tilt, and mounting height. But the modules do operate in a more ventilated environment, especially when compared with a tight, flush-mounted roof installation. The difference becomes most valuable on the same afternoons when the house is consuming the most power. At 3 in the afternoon on a hot day, the air conditioner is working hard. That is precisely when you do not want the array losing more output than necessary to trap heat. There is also a second benefit that does not appear on the inverter display. The gazebo shades the patio and part of the house. Before the build, the western side of the property absorbed direct afternoon sun. The patio surface stayed hot into the evening, and the nearby doors and windows received significant solar exposure. After the gazebo was installed, that area became usable during the day, and the shaded zone also reduced some of the heat reaching the adjacent wall and glass. That is what makes this approach different from a standard ground-mounted array. The same square footage performs two jobs. It generates electricity above and creates useful space below. But there is a trade-off most videos skip. A solar gazebo can be harder to permit than a rooftop system. A building department immediately understands a conventional roof array, and many jurisdictions have standardized drawings and expedited approval paths for it. A gazebo carrying solar panels may involve both structural and electrical review. It can trigger rules for accessory buildings, setbacks, height, drainage, fire access, and lot coverage. Depending on where you live, you may need stamped structural plans, and you may encounter an inspector who has never reviewed this exact combination before. The best way to avoid delays is to speak with the planning and building departments before finalizing the design. Bring a basic site plan showing property lines, the house, the proposed structure, its height, and the distance to nearby boundaries. Ask how the project will be classified. Do not order the entire system and then discover that the gazebo violates a setback by 18 inches. The same caution applies to electrical work. Solar arrays can produce dangerous direct current voltage even when the utility breaker is off. Proper wire sizing, overcurrent protection, grounding, bonding, rapid shutdown requirements, disconnects, and labeling are not optional details. The structural portion may be a realistic do-it-yourself project for an experienced builder, but the final electrical integration should be handled or reviewed by a qualified professional familiar with solar and energy storage systems. Now here is the number everyone wants. What did it cost? The answer depends heavily on how much labor you perform yourself and how much battery capacity you purchase. For this type of build, the panels, rails, structural material, concrete, wiring, disconnect equipment, inverter, and batteries can place the project somewhere between the low five figures and well above $20,000. The gazebo frame itself may be relatively affordable, but the batteries are usually the biggest variable. A system intended to carry essential loads overnight costs far less than one expected to run central air conditioning, electric cooking, water heating, and every household circuit through multiple sunless days. The smartest money spent on this project was not on additional panels. It was spent reducing unnecessary load. LED lighting, better weather sealing, efficient appliances, smart scheduling, and careful circuit selection lowered the amount of generation and storage required. That is the larger principle behind a reliable off-grid system. Efficiency comes before capacity. Every watt you avoid consuming is a watt you do not have to generate, store, convert, cool, or replace later. This gazebo works because the project was not treated as a collection of impressive equipment. It was treated as a complete system. The structure handles weather, the panels produce energy, the inverter controls power flow, the batteries carry the house after sunset, the transfer equipment protects the grid connection, and the household adjusts consumption when conditions are poor. That is what self-reliance actually looks like. It is not pretending the weather does not matter. It is understanding the limits of the system well enough that a cloudy day, a utility outage, or a failed generator does not become an emergency. The gazebo also changed how the backyard is used. It is now a shaded place to work, eat, store equipment, and wait out a power outage without sitting inside a dark house. The electrical value is important, but the structure earns its space even when the batteries are full. Would I recommend a solar gazebo to everyone? No. It makes the most sense for a property with strong solar exposure, enough yard space, reasonable permitting rules, and a homeowner who already wants a covered outdoor area. A shaded lot, a restrictive homeowners association, or a very small backyard may make rooftop solar the better choice. But where the conditions are right, combining the array and the outdoor structure can be far more useful than treating them as separate projects. The question is not whether a gazebo can power a house. This one does. The question is how long you expect it to power the house, which loads you consider essential, and what you are willing to change when the weather does not cooperate. So before you compare panel brands, answer this. If the grid went down for 7 days, which parts of your house would you refuse to live without? Put your answer in the comments, and then watch the next video on sizing battery storage from real household loads. That calculation will tell you more about whether your off-grid plan is realistic than any panel advertisement ever will.